Okay, so we have graphed linear relations that have been oblique, and oblique lines are slanted lines. So you'll notice that the lines go at a diagonal, like all the other lines or all the lines that we've graphed so far. Of course, there's an exception to the rule. There are also lines that are both horizontal and vertical. So if you looked at all the equations of our oblique lines, you notice that there was a dependent variable and an independent variable. Well, in horizontal and vertical lines, we're only going to have one. Okay, so let's just kind of go through go through the lesson, and I think you'll understand what I'm talking about. Before we can continue on, we need to know some terminology. X-intercept is where it is a point. Notice that I have ordered pairs. It is the point at which the graph crosses the x-axis. So if this was t, then this would be the t-intercept. Okay, so just because it's the intercept of whatever variable you give it. Same thing with y-intercept. It is the point at which the graph crosses the y-axis. Remember, y is up and down. Remember, it could be distance, it could be velocity, it could be any variable. So that would just be the d-intercept or the v-intercept. But it is a point. Notice I have ordered pairs. So this is your x-intercept. This is your y-intercept. Okay? So here we did a little bit of a math lab and I tried to have the students investigate and see if they can kind of come up with their own little interpretation of what the rule is. From there, I gave them the rule or the notes, and hopefully most students got on to the fact that an equation of a horizontal line always takes the form of y is equal to k. Now here's this would be your dependent variable. This is your parameter. This one's going to change. Okay, so that's your parameter. It is going to be a number. And you don't get an equation just with y is equal to k. You need a number in there. Okay, well that k is going to be the y-intercept of your line. So here, notice that in the example, here's my line. I look at the y-intercept. It's 1. Actually, it is 0, 1. So it's going to be y is equal to 1. Now, take a look and see that the horizontal line will cross the y-axis. Well, that's why we have y. And where does it cross the y-axis? Well, it crosses it at 1. So that's where you get the equation y is equal to 1. Okay? So that was a horizontal line. Now let's talk about the vertical lines. Again, in the math lab, the students investigated this. So vertical lines go up and down. They will always take the form of x is equal to a, and again, this is the parameter, this has to change. This is your dependent variable, this is the parameter that will change into a number to give you a line, to tell you which line it is. Well, the a in this case will be your x-intercept. So notice in the example that my x-intercept is 1.50. Whoops, that's a point. So, and since all vertical lines cross the x-axis, you're going to get x is equal to 1.5. Okay, that's just an easy way to remember it. Well, let's do a couple of examples here. So we have to match these equations with these lines. Now there was a mistake here. I have to change that. This is supposed to be -5, not -4. I actually have to change that. Okay, well, let's see. Let's talk about this line. Which axis does it cross? Well, it crosses the y-axis. And where does it cross it at? Oops, I was wrong. That wasn't the mistake. It crosses it at -4. So this actually is y is equal to -4. But I do know there's a typo somewhere in here. I'll have to find it. So this is y is equal to -4. It crosses the y-axis and it crosses it at -4. 0, 0, negative 4. So that's the equation that matches that line. Well, let's go over here. Again, horizontal line crosses the y-axis. It crosses it at 0, 5. So it is y is equal to 5. Okay. Vertical lines cross the x-axis. We're crossing it at positive 5, 0. So x is equal to 5. This is the one I made the mistake on. I'm just going to change that to 4. Okay, actually I'll just put it over here. Vertical line crosses at negative 4, 0. So your equation is x is equal to negative 4. So don't make this harder than it actually is. That's it. It's done. Let's do a few more examples. Oh, this was just a little thing that I found. I thought it was kind of cute. So x is equal to negative 2. Okay, so x is equal to negative 2 has to cross the x-axis at negative 2. Notice that it only has one variable, so I know it's not an oblique line. I know that all vertical lines cross the x-axis, so it has to be a vertical. This is x, 2x is equal to 6. So I have to say x is equal to 3. Like I have to simplify it so that it's, like I'm dividing both sides by 3. So I know that that is also a vertical line because it has to cross the x-axis. Y is equal to 3 has to cross the y-axis. The only way you're crossing the y-axis is if it's a horizontal line. In this one, y divided by 3, this is actually y is equal to 9 because 9 divided by 3 is 3. Crosses the y-axis. The only way you're going to cross a y-axis if it's horizontal. Now this one's a little bit, these two are a little bit trickier because we actually have to subtract negative 4, or sorry, subtract 4. So this is actually this line. We have to put it x equal to in order to figure out what that x-intercept is. Okay, so since x is equal to, we cross the x-axis, it has to be vertical. This is y minus 1 is equal to 0. So really, if you wanted to see where it crossed, you would add 1 to both sides. And you would actually get the equation y is equal to 1. It is a horizontal line that crosses at 0, 1. So it has to be horizontal. Okay. Describe the graph of the line y is equal to 3. Notice that I only have one variable, so I know it either has to be oblique, or sorry, I know it has to be either horizontal or oblique. Oblique lines are the only ones that have both variables. So since it's y is equal to, it must cross the y-axis. It crosses it at negative 3. So don't go nuts here. That's your line. Okay, crosses the y-axis. We should label our axis though. Crosses the y-axis at negative 3. So it must be a horizontal line. Now in order to create your table, it does not matter what your x is. It's negative 1, negative 3, 0, negative 3, 2, negative 3, 5, negative 3. It doesn't matter how far you go this way, you are always going down to negative 3. Okay, so it doesn't matter. Notice that all your y's are equal to negative 3, and that's why we have the equation y is equal to negative 3, because it doesn't matter what your x is for horizontal lines. Okay, different types of types of questions that you might get on your test. Which of the following equations will be a vertical line? That one's oblique. This one crosses, this one's oblique because we have both the x and the y, so let's just cross that out. So this one crosses the y-axis, so that has to be vertical. This one crosses the x-axis. So, I keep on getting, my apologies. This one crosses the y-axis, so it must be horizontal. This one crosses the x-axis, so it must be vertical. So the answer is D. Which of the following equations will be a line that is parallel to the x-axis? Okay, well, let's just draw a picture. Okay, here's my x, here's my y, there. So a line that's parallel to the x-axis is actually a horizontal line. Sorry, I'm sneezing over here. So this is oblique, that's oblique. Okay, so get rid of your oblique lines. The ones that have two variables in it are oblique. They're slanted. We've dealt with those. So since a horizontal line crosses the y-axis, it has to be a y is equal to. Okay? So let's talk about the equations of these lines. We have a red line, it crosses, it's a horizontal line that crosses at 0, 4. So it has to be y is equal to 4. Crosses the y-axis at 4. Y is equal to 4. So plot the points negative 2, 8 and 4, 8. Okay, well so negative 2, 8. So let's go 4 and 8. Let's go up by that. And let's go negative 2, 2. Oops. Sorry, I'm getting binged here. Okay, so I have enough information. So here's negative 2, 8 and 4, 8. Okay, I'm just going to put this in red. So notice I have a horizontal line. That's the only way that I'm going to connect those 2 points together. So I have y is equal to 8. So the y-intercept, again, it's a point. Don't just say 8, it's a point. 0, 8, that's your y-intercept. It has no x-intercept, none, and it is parallel to the x-axis. Okay, perpendicular to the y, parallel to the x. So just a different way that you can ask the exact same question, that I can test you that if you know the definition of horizontal and vertical lines and be able to come up with the equation. Okay, so here's, again, if you don't get it, draw pictures. They help out. So what is the equation of the y-axis, and explain your thinking? Okay, so the y-axis is just this. Well, it's a vertical line, and where does it cross? Crosses at 0, 0. So it has to be x is equal to 0. Okay, so it's still a vertical line. It does have an equation. And yeah, it's just x equal to 0. So again, using the exact same rules. Write the equation of the horizontal line that passes through point negative 5, negative 1. Okay, well, let's just draw a picture. And again, negative 5, negative 1, 1, 2, 3, 4, 5, negative 1. Okay. And we want a horizontal line. Horizontal is like the horizon. It goes side to side. Okay, so since we have a horizontal line, let's label our axis. Don't be lazy. It crosses the y-axis, so we know its y is equal to, and it crosses it at negative 1. And we are done. You can go y plus 1 is equal to 0 if you want, but this is the one that will be on your test, I'm pretty sure. Okay. And that's it. So we've learned that linear relations come in 2 different forms: slope, intercept, and standard. That was what we covered in part 1 of this lesson. Then we talked about horizontal lines. We talked about vertical lines, and they only have one variable, where oblique lines have both variables. They have both the independent and the dependent variable. And we learned how to graph both horizontal and vertical lines. So of course you have some questions there. I do want you guys to hand in the assessment focus to me, just so I can do a little check-in. So I hope this video helped, and have a great day.